Amigos, ¿qué pasa? We are at the Glacier Museum. Yes, so right behind me, we were there yesterday. Amazing places. The glaciers themselves are there, so what are we doing here? Maybe you're wondering. But actually, there's a theory that says that maybe these glaciers, which are gigantic, I never even imagined how massive they are. It's possible that a fragment of an ice dome has been preserved in these glaciers. Which, well, in the era when there were large dinosaurs, when truly gigantic creatures could walk on this planet, and their spines didn't break the way ours would instantly. If we were even 5 meters tall, we wouldn't be able to function at the current atmospheric pressure. But if we assume that the planet used to be covered with an icy crust, let's say up above, high up, then a lot of things, by the way, start to make sense. And that's why we came to check. And of course, like a real fool, I was sure that it would be possible to go in, get close to the glacier, approach the glacier, dig into it with a little knife, take a sample and bring it to the lab to see if there are any air bubbles in it or not. In reality, that's complete and utter nonsense. So, I'll tell you, yesterday we were at a glacier that's constantly moving. That is, it's a gigantic mass of ice that's moving at a certain speed. Just so you understand, in 100 years it moves 70 kilometers. This is happening there constantly with a wild roar. Everything is collapsing. Every 5 minutes, huge chunks break off and it keeps growing all the time. So there are a ton of natural reasons for the formation of this ice. Really, there are mountains and we're practically at sea level. And all the fresh water, which, as we know, somehow magically gets delivered to the very tops of the mountains, yeah, some kind of planetary hydraulics pumps it up there. That's a very interesting question. We'll definitely bring it up again. So accordingly, this water flows down there and freezes. It really turns into a gigantic mass. This glacier is 300 kilometers long. That's the total if you count all its parts. And it's about a kilometer deep there. Yes. But does the presence of natural causes mean that there can't be fragments of the dome there, inside, somewhere with different ice characteristics? No, it doesn't mean that. But to check this, of course, I can't do it alone. A powerful expedition is needed here. You need to drill about a kilometer deep. You need to extract a core sample and study it. I don't know, maybe this has already been done. And to answer this question precisely, we came to the Glacier Museum. Let's see what's there. Surely someone has drilled it. Let me tell you, these are the most beautiful places I've ever seen in my life. Here, for billions of years or however long, I'm not sure exactly, but since the moment this planet has existed, no one has done anything there at all. Everything is absolutely pristine. Let's go to the museum. Guys, this is really funny. At the entrance to the museum, there's this thing hanging. It's a stone that shows the weather. So if the stone is wet, it means it's raining. If the stone is dry, then there's no rain. If the stone casts a shadow on the ground, it means it's sunny. If the stone is white on top, it means it's snowing. If you can't see the stone, there's heavy fog. If the stone is swaying, it's windy. If the stone is bouncing, it's an earthquake. If the stone is underwater, it's a flood. If the stone is gone, it's a tornado. Cool. Let's go to the museum. The Glaciarium Glacier Museum in El Calafate is a modern interpretive science center dedicated to the study of and public education about Patagonia's glacier systems. The architecture of the museum is done in an avant-garde style, reminiscent of the sharp and fragmented shapes of glacier masses. Combining a scientific approach and advanced technologies, Glaciarium offers visitors a comprehensive understanding of glacier dynamics, their geological features, and changes caused by climatic factors. The museum's exhibition includes several thematic zones, each relying on data visualization and interactive technologies. Visitors can explore the process of glacier formation, starting with snowfall and the compaction of snow into ice masses, as well as learn about the movement of glaciers under the influence of gravity and their interaction with the surrounding landscape. Interactive panels, animations, and 3D films vividly demonstrate the processes of ablation, fragmentation, and melting of glaciers, providing visual evidence of the impact of climate change on their condition. A separate section is dedicated to the study of ice cores, which serve as natural archives of climate changes over the past millennia. One of the features of the museum is the Glaciarium bar, an ice bar where the environment is recreated from ice, including the walls, furniture, and decorative elements. At temperatures of about -10 degrees, visitors can get a vivid sense of the climate typical of glacier environments. The Glaciarium Museum in El Calafate not only helps the public understand glaciers, but also plays an educational role, emphasizing the importance of preserving these natural formations as indicators of climate change and key elements of the global water balance. Oh, here it is. This is... Here, these are the cores they studied. Temperature. These years, 800,000 years. In short, they drilled back 800,000 years. And every year they see it, friends. Now that's real science. You can't argue with that, damn it. And this is how the ice temperature changed. So you can see that it ranges from +4 to -10. There was probably a drop in the average annual temperature at this point. Yes, so here they are, the ice ages or periods of global warming, yes. We're just in another one right now, so you see how regularly they occur. There's no need to worry. Everything's fine. That's it, the ice recorded everything. And that's absolutely accurate information. Yes, friends, this is what the glacier looks like. We were right here just yesterday. Down below, on the ship. Yes, the speed is 700 meters per year. In 100 years, this glacier tongue advances 70 kilometers. Its depth above the water, actually its height, is up to 200 meters in some places. 150 meters consistently, and it goes down to a kilometer deep underwater. So this area here is already above freezing. Plus there it's 13 degrees, that's where we were yesterday. And up there, where the snow is lying, that's the 0 degree zone. Everything below this zone starts to crack and break off. It breaks off in an epic way. In short, you should never approach it closely by ship under any circumstances. Yeah, don't even think about it. Oh, and this is where we're going tomorrow. This is Fitz Mountain anyway, it's very famous. Alright, let's move on. This is really interesting, to be honest. This is real science. Alright, this is cool. This is a map under our feet. Damn, this is the coolest museum I've ever seen. This is a map of the glacier, wow. And all of this is really cool, of course. Here is our city. You can even see it right here. Here it is, Perito Moreno. And here are our two from yesterday. Yes, everything here is covered in icebergs. We didn't go there, it's not allowed, but here is where we were yesterday. This is the huge one that moves 70 kilometers a year. Yes, and they say this whole glacier is 300 kilometers long, and maybe, yes, it hides some surprises deep inside. A glacier is a moving mass of ice formed by the accumulation of snow over time. Glaciers have two zones, the accumulation area and the ablation area. The accumulation area is located in the highest and coldest parts of the glacier. There, snow falls and turns into ice. In the lower sections it is less cold. And there, due to melting, evaporation, sublimation, and landslides, the glacier loses mass. This is the ablation zone. The glacier separates both zones. This is the section where gain and loss are equal. The mass balance allows us to determine whether the glacier is growing, shrinking, or remaining stable. If ice production was greater than its loss, the glacier grows. If the losses were greater than its production, it will shrink. If accumulation and ablation were the same, the glacier would remain stable. Ice caves. They are beautiful and seem full of mysteries. With their help, nature demonstrates its most creative side. Meltwater streams, the passage of time, air, and water create these wonders. Why is glacier ice blue? One of the most amazing phenomena that strikes people when they see glaciers is the deep blue color of the ice. So why does ice look blue if it's made of water which is colorless? White light consists of all the colors of the spectrum. Blue wavelengths of light carry more energy than red and yellow, so the light penetrates deeper into the ice. When light travels long distances, red and yellow light are absorbed while blue remains. That's why we see stunning shades of blue, turquoise, and indigo in caves, crevasses, icebergs, and glacial formations. Glacial tables are a curious phenomenon that occurs when ice melts around a large rock. These rocks, sitting on the surface of the ice, protect it from the sun's rays. Thus, melting happens more slowly in this area, leaving a column of ice and rock that resembles a table. Glacial erratics are large rocks that were carried and then left behind by glaciers. Their current location indicates the size of ancient ice sheets and the movement of glaciers in the past. Glacier mills. The glacier seems alive. It moves quietly and almost imperceptibly, creaking, squeaking, crawling, constantly changing. Meltwater turns into streams, and as it begins to flow, forms meanders on the frozen surface of the glacier. When a stream of meltwater finds a weak spot in the ice, it cuts through it, forming glacier mills. These holes are usually cylindrical in shape, eroded by water that flows inside the glacier, seeking to reach the ground. As more and more water finds its way through the glacier's deformable ice, streams and waterfalls form inside the glacier. The water carves its way for thousands of meters before reaching the base of the glacier. This creates a natural glacier drainage system consisting of tunnels, caves, sinkholes, glacier shafts, and wells. Icebergs. You can hear the roar when the glacier calves. It falls slowly, at a speed that seems unreal, belonging to another dimension. It sings and looks like a colossal gemstone filled with shades of blue, indigo, crystalline blue, electric blue, lapis lazuli, and turquoise. It starts its journey to its destination. It will float until it disappears. Icebergs. These are impressive floating masses of glacial ice. They drift in lakes and oceans, breaking off from glaciers. They can reach many kilometers in length and rise dozens of meters above the water's surface. But the visible part of an iceberg makes up about 10% of its total volume. The rest is hidden beneath the surface. Snow becomes a glacier. Snow is the raw material of a glacier. As snow accumulates and compacts, it turns into firn and then into ice. Beneath the surface of the snow there is a crust called firn. This crust remains from previous winters. Firn. It's an intermediate state between snow and glacial ice. Its crystals are very compact, but the air spaces are still connected to each other. Over time, pressure will continue to compact the snow. The bubbles trapped in the ice are isolated from each other. From the softness of snow, solid glacial ice is born. Moving sculptures. Glaciers are in constant motion. They deform plastically under the stresses created by their weight. They slide along their bed when water between the ice and the rock lubricates and makes sliding easier. Glaciers are in constant motion. The ice in them deforms plastically under enormous pressure and stress. The average speeds of glaciers vary. Some move only a few meters per year. Others move several meters per day. Surging glaciers are those that suddenly accelerate their movement. During these periods, the speed of movement can increase up to 100 kilometers. The presence of glaciers leaves a powerful mark on geography and landscape. They are architects, shaping valleys, lakes, fjords, mountains, and forming moraines. As the mass of ice destroys the terrain, rocks and deposits get into the glacier, which will be carried over long distances. The deposits formed as a result of the ice's advance are called glacial debris or moraines. Moraines, which the glacier drags and presses against the bedrock, act like sandpaper. They polish and grind until they turn the rock into powder or rock flour. To sum up, I believe that the hypothesis about the presence of some fragments of an ancient dome inside this giant glacier is still valid and remains possible. But drilling was definitely done here. They drilled samples going back 800,000 years. And I'm sure that if they had found some fantastic layer of ice there that was different, we would definitely know about it. I don't think they're hiding anything from us, but to be sure of that, you need a pretty serious expedition. You need to drill at least 3 holes all the way down. Yeah. So we went out, and let me tell you folks, everything works. The weather forecast is excellent. Apparently it's windy. Yes, the weather is about to change. Well, that's fine. So shall we fly?